Good morning, students. So this is our second class on vectors. In the last video, explained about the introductory ideas regarding vectors. We discussed how to resolve a vector into its components. We also discussed how to add two vectors, more than two vectors, and so on. So that was an introductory class. Today, we would use those concepts to solve some simple numericals, and slowly, gradually, we'll proceed to solving some more complicated ones. The first one, suppose there be a vector, I'll call it as A vector, and its magnitude is given as 5 units, and you are given x and y axis like so. This vector makes some angle, say 30° with x-axis. Question is, find y component of this vector. Very simple question. So the projection or component of a vector along some direction, how do we find? We multiply the magnitude of that vector with cosine of angle between that vector and the direction along which its component is to be found. This vector makes 30° with x-axis, so it means it will make, so this is the question, solution. So angle made by a vector with y-axis. Now why do we choose y-axis? Because we have to find y component of that vector. Is how much? 90 minus 30°, that is 60°. Therefore, the y component of a vector, which we denote as ay, will be its magnitude a times cos of 60°. Now its magnitude is given to be 5 units, so the answer becomes 5/2 units, because cos 60 is half. So this example illustrates how do you find component of a given vector along some direction. Having understood this, let us see next question. Question 2. Suppose we are given a set of vectors and we have to find their resultant. So let me draw the figure for you. This is x-axis, this is y-axis. Suppose there are three vectors. One vector is like so, other vector is like so, and third vector is like so. There are three vectors. This is C vector, this is B vector, and this is A vector. Okay, and the angles are like so. This is 37°. Or let me simplify this angle to 45°. And here the C vector makes an angle of say 60° with this direction. The question is, find the resultant of these three vectors, A vector, B vector, and C vector. Suppose the question is like so. So solution, let R vector be the resultant. Now when we say R vector is the resultant, that means this vector is the cumulative effect of operating these three vectors one after the other or simultaneously. For example, suppose this vector speed displacement. A person moves in this direction to this point. Second step, he moves horizontally to this point. Third step, at an angle of 60° with x-axis, again moves to some distance to this final point. Now these magnitudes are given to you. It is given that this length, and this length are same. So A is equal to B is equal to C, where they are magnitude of the vectors, and that is given as suppose 10 units. Let me simplify it to meters only. Consider it as a displacement. Now r vector is the resultant. So it is obvious the resultant will be from the initial position to this final position. So that will be this vector. So this is not looking straight, but it should be a straight line joining this point to this point. So this is our resultant. Now if we have sufficient information regarding geometry, this question on vector reduces to a question on geometry. Okay. So you can see there are some triangles, some sides are given. This is, for example, 10, this is 10, this is 10, these angles are given. So you can find this using geometry, but we also use a traditional approach. If r vector is the resultant, we know students r vector will be written as sum of these three vectors, a vector plus b vector plus c vector. So we will find the x and the y components of the resultant as the sum of x and y components of the vectors a, b and c. If r is a vector plus b vector plus c vector, the x component of the resultant must be equal to x component of a vector plus x component of b vector plus x component of c vector. And likewise, we have the relation for the y components. So ay plus by plus cy. So let us find these resultants by finding the values of ax, bx, cx. Now see, vector A makes how much angle with x-axis? It is 45 degree. So we will find x and y components of vector A. Since it makes angle of 45 degree with x-axis, it will also make an angle of 45 degree with y-axis. So ax will become a cos 45. This will also become a cos 45 because both the axes are at 45 degree with this vector. Now the magnitude of A is given in the question as 10 meters and cos 45 becomes 1 by root 2. Likewise, let us find the components of B vector. First to say B vector is horizontal, parallel to the x-axis. Since it is parallel to x-axis, we say it makes 0 degree or no angle with x-axis and it must be perpendicular to y-axis. So with x-axis it makes 0 degree, so we'll write cos 0, and with y-axis it is perpendicular, so we'll write b cos 90. Cos 0 is 1, value of b is 10, so the answer remains 10 meter, and this becomes 0. Cos 90 is 0. You could have understood it directly, students. Since this motion is exactly horizontal, it cannot have a component in vertical direction, so its y component must be 0, and its x, the entire vector lies along x-axis, so its x component is 10 meter, and then we are left with the x and y components of c vector. So c vector makes how much angle with x-axis? Now with x-axis, which is parallel to this line, it makes an angle of 60 degrees. So we'll write 60 here. If it makes 60-degree angle with x-axis, it means with y-axis, it should make 30-degree angle. So here we'll write cos 30. Now cos 60 is half, so we'll have 10 by 2, that is 5 meters. Cos 30 is root 3 by 2, so root 3 by 2 into 10 will have 5 root 3 meters. This is our first step to find the components of all the vectors. Now instead of 3 vectors a, b and c, if we are given 10 vectors, all those vectors resolve them along x and y axis. So we'll get ax, bx, cx, dx, ex, fx, gx and so on till 10 components. Likewise, find the 10 components along y axis, then proceed in similar fashion as we are discussing. So it's not important how many vectors are given. Whatever be the number of vectors, always resolve them along x and y axis. That will give you Rx and Ry, the x and y components of resultant after addition. And from there you can easily find magnitude and direction of the resultant. So Rx, which is sum of Ax, Bx and Cx, will be you see this one, 10 by root 2 plus bx is 10 and cx is 5. Now, if you wish, you can take 5 common, you can take LCM and you can simplify it a bit. I'm not going to do that. Ry, my intention is just to discuss the method. Ry will be, you see, ay plus by plus cy. So ay is 10 by root 2, by is 0, and cy is 5 root 3. So these are the x and the y components of the resultant. So therefore, our answer will be resultant vector. We know any vector can have components along x and y axis, rx and ry in this case. So we can write that vector as rxi cap plus ryj cap. So our entire answer becomes something into I cap, something into j cap, where this something is nothing but Rx, which we have calculated over here, 10 upon root 2 plus 10 plus 5. Right, so that 15 there, in fact. It doesn't look good if I write 10 plus 5, I'm writing it directly as 15. So this becomes 15. And then Ry becomes 10 upon root 2 plus 5 root 3. So this is our complete answer. So if they have asked you the resultant, this is the resultant. Now, instead of asking the component form, if in question they have asked specifically the magnitude or value of the resultant and its direction, then you'll proceed a bit more. Magnitude of this vector, let me remind you, if we have any vector like so, then its x and y components are like so. This is ax, this is ay. So its magnitude is this length, which according to Pythagoras theorem can be obtained from ax and ay values, root under ax square plus ay square. And if it makes some angle alpha with this axis, x component, then tan alpha is y component by x component. So with this in mind, we can easily write the magnitude of r vector is equal to under root rx square plus ry square. Now the rest is mathematics, which I will not do here. Instead of rx and ry, you have to put the values, and then you can simplify it to the extent you can. If r vector makes angle alpha with x-axis, then tan of alpha should be y component of r by x component. So this becomes ry upon rx means 10 by root 2 plus 5 root 3 divided by x component, that is 10 by root 2 plus 15. So this is our tan alpha, therefore alpha will be tan inverse this value. So root 2, if you take LCM, it will cancel. You will be left with 10 plus 5 root 6, 10 plus 15 root 2. 5 also will be common, you can cancel it, you can do it yourself. So if we are given some vectors, this is the method. First, all those vectors, find the x and y components, step number 1. Then the x component of resultant will be sum of the x components of all the vectors. Y component of resultant will be sum of y components of all the given vectors. Once you have got rx and ry, you can express the vector as its in terms of its x and y components, like so, using the unit vectors I cap and j cap. And if direction and magnitude are given, you will have two more steps. Magnitude will be under root x component square plus y component square, and if it makes angle alpha with x-axis, then tan alpha will be y component by x component. So this is the method for solving that. Let us now discuss some more questions. Now there is a term called as equilibrium, students. We say if the sum total of all the forces acting on a body is zero, then that body is said to be at equilibrium. For example, right now this duster is at rest over my palm. So whatever be the forces acting on this duster, all those forces must add to give zero resultant. Then we say the object to be at equilibrium. So based on the ideas of vectors which we have discussed so far, now we are in a position to discuss questions on equilibrium also. Let us discuss. Suppose it is given the sum of the body under action of three forces F1 vector, F2 vector and F3 vector is at equilibrium. And the figure is given in the question. Suppose this is our x-axis, sorry, y-axis, x-axis. So we have one vector like so. Second vector like so. And there is third vector like so. This is F1 vector, F2 vector and F3 vector. And in this question, you have to find the magnitudes of F1 vector and F2 vector given F3 vector's magnitude is 20 Newton and F3 vector makes an angle of 60 degree with this particular direction. So here in this figure, there are three vectors, F1 vector, F2 vector and F3 vector. Out of those three vectors, two of the vectors are not of known magnitude, these two. We have to find their magnitudes, values. And what is given to us is the value of this vector, that is 20 Newton, and this direction, that is 60 degree. Now this term might be new, but I told you its meaning. If it is given that the body on which these three forces are acting, so there is a body, one force is acting tilted like so, one force is acting towards we say this direction, and one force is say downward. So these three forces must add up to zero. Statement number one, since the body is at equilibrium, this implies the resultant F vector. So let me write, let F vector be resultant force on the body. So F vector, which should be F1 vector plus F2 vector plus F3 vector, must be how much? Zero. Such a vector will be called as a zero vector. Okay. So this is not a scalar zero, this is vector zero. Okay. It has a zero magnitude. Now how to deal with this question? Again, if this is so, we have already discussed the x component of the resultant force, which is F1x plus F2x plus F3x must be zero, equation number one. And we should also have Fy, the y component of the force, should be F1y plus y component of F2 and plus y component of F3, and that also must be zero. If the resultant force is zero, that is possible only if its x component is zero and its y component is zero. Because if we have either of them to be non-zero, then the total vector cannot remain a zero vector. So let me repeat the concept. Since the object is at equilibrium, the sum total of all the forces must be a zero force, zero vector. That will be possible only if the x component of the resultant force is 0 and the y component of the resultant force is 0. So we have 0 I cap plus 0 j cap. That is the resultant. Now rest I think you can understand. So from 1, so fx value is 0, so I'll write 0 is equal to f1x, x component of force 1. F1 vector is this one. We do not know its value. So its x component will be f1 into cos angle which it makes with x-axis, that is 0 degree, plus x component of f2. F2 is in this direction. It makes 90 degree with x-axis, this one. So here we'll write f2 times, you know how to find the components, cos 90. Cos 90 plus x component of f3, this one, f3x. Now f3 is making how much angle with positive direction of x-axis? You can say it is making 120 degree. So f3 times cos 120 degree. You could have straight away written this component as minus f3 cos 60. If you see carefully, this f3 can be resolved. This component will be f3 times cos 60. Instead of writing f3 cos 120, you can also write f3 cos 60 in this direction. But we want component in that direction, so we'll put a negative sign, minus f3 cos 60. Anyway, either way you can solve it. Let's solve this. 0 is equal to f1 we have to find. Cos 0 is 1. Cos 90 is 0, so this becomes 0. And then f3 times cos 120 degree. Now cos 120 degree will be minus half. It is cos 90 plus 30. Cos 90 plus 30 will become a minus sign 30. That will become minus half. And if you see this, here also you will get the same answer. So this gives us the value of f1. This negative sign, when you take it to the other side, it becomes positive. F3 upon 2. But F3 value is given in the question to be how much? 20 Newton. So this becomes 20 Newton upon 2. So answer becomes 10 Newton. Let's now find the other part. So we have got F1. F1 is 10 Newton. Now for finding F2, which is along y-axis, we shall use this equation. So Fy value is 0. So this implies 0 is equal to y component of F1. Y component of F1 will be F1 into cos of angle which this vector makes with y-axis. This F1 vector makes 90 degree angle with y-axis. So we'll write cos 90. Then F2. F2 is in this direction. Cos of the angle which F2 vector makes with y-axis. Now this is the positive direction of y-axis. This is plus y. So this angle has to be found. So this is 180 degree. So we'll write cos 180 degrees plus F3y component. This is F3 vector. So its magnitude I write as F3 into cos of angle which it makes with y-axis. This is F3 vector, this is y-axis, this angle you need to know. Now this angle will be 90 minus 60 degree, that is 30 degree. So cos 30 degree. So let us simplify it quickly. Cos 90 becomes 0. So we get 0 is equal to 0 plus cos 180 is minus 1, so it becomes minus F2. And then cos 30 is root 3 by 2. So minus F2 comes this side, so it becomes F2 is equal to F3. F3 is 20, so 20 times root 3 by 2, that is 10 root 3 Newton. So I hope this solution is clear to you. So these are some simple applications of what we have discussed so far. How to resolve vectors, how to add two vectors, and so on. So having understood these examples, it will be easy for you to do some more complicated ones. So that the such questions we will not do today. So this is the second class on the vector. Such complicated questions we will be doing in next class. Clear? So if you have understood this, we will discuss one more question. Suppose we have a question like this. There is a circle. This is x-axis and this one is y-axis. This you can take as the origin. There are three vectors. This is vector A. Then there is another vector like so. And there is third vector like so. At an angle of 45 degree. You have to find the resultant of these three vectors. So this is O. I can name this as A, I can name this as B, I can name this as C. So the question is find. Let us write the question. Instead of finding resultant, let us find a vector R which is twice of OA vector minus OB vector plus twice of OC vector. Now this is not resultant. Resultant, when we use that term, we mean sum of those vectors, A vector plus B vector plus C vector plus D vector and so on. But here this operation is a bit different. We don't have to find a resultant, but there is what we have to do. We have to take a vector which is twice as, whose magnitude is twice as high as that of OA vector. From that we have to subtract OB vector, and then to that we have to add a vector whose magnitude is double of OC vector. So although this question looks different, but the method will be exactly similar what we did just now. The first step will be to obtain the x and the y components of all those three vectors. So the concept remains same. If r vector is equal to this much, the x component of r vector we'll find first, then we shall find y component of r vector, and then we will use r vector is equal to rx I cap plus ry j cap. Now the x component of r vector, looking into this equation, you have to write. It will be twice of x component of OA vector, I write as OAX, minus x component of OB vector, OBX, plus twice of x component of OC vector, OCX. Similarly, we will write the y component of r vector as twice of y component of OA vector, we will write as OAY, minus y component of OB vector plus twice of y component of OC vector. So now we need to find the x and the y components of these three vectors which are given in the question. And it's given that r is the, let A is the radius of this circle. That means this length is A, this length is also A, this length is also A, because they are all radius of the circle. Okay, let us directly do it. So Rx is equal to, first one, 2, so write 2. X component of OA vector will be the magnitude of OA vector. Magnitude of OA vector is this length. This length is given in the question as A, into cos of angle which that vector makes with x-axis. OA vector makes 0 angle with x-axis. I'll write 0. And then we have minus x component of OB vector will be A, its magnitude, into cos of angle made by OB vector with x-axis. Now this is OB vector. It makes 45 degree with x-axis. So we'll write cos 45 degree. Okay. Now I think you can easily say what will be the third term. That will be plus twice of x component of OC vector. Now OC vector magnitude is also A. Its x component will be cos of the angle which OC vector makes with x-axis, that is 90 degree. So straight away cos 90 becomes 0. So this becomes 2a, cos 0 is 1, minus cos 45 is 1 by root 2. So a upon root 2. Likewise, we will find ry. 2 A into cos of angle made by OA vector with y-axis. OA vector makes 90-degree angle with y-axis, so this becomes cos 90 minus y component of OB vector. Magnitude of OB vector is A, and this vector makes 45-degree angle with y-axis, so this again becomes cos 45-degree plus twice of y component of OC vector. So OC vector magnitude is A, and it makes 0-degree angle with y-axis, so this will become 0-degree. Solving, so cos 90 becomes 0, so this becomes minus A upon root 2 plus 2A. Now it's interesting to find that Rx and Ry, both of them have same magnitude. This can be written as 2A minus A by root 2 and so on. So R vector, which is our parameter R vector, which is our 2OA vector minus OB vector plus 2OC vector, this will be written as its x component times I cap plus y component times j cap. This becomes, the x component is 2A minus A by root 2 times I cap, and its y component would be plus, that is also same, here we have got, so 2A minus A by root 2 times j cap. So these are the x and y components of R vector, so we can express our answer in terms of this. So if they have asked to find R vector, you can stop till here, but then as I told, if you are asked separately and specifically find the magnitude and find the direction of R vector, then you will have to proceed a bit more. So for magnitude, R vector magnitude, students, you know, it is under root Rx square plus Ry square. But if you see carefully, since Rx and Ry have same values, so I can write Rx square plus Rx square, 2 Rx square, so it becomes root 2 times Rx after taking a square root. So its magnitude will be root 2 times 2A minus A by root 2. Then direction. Let R vector make angle alpha with x-axis. If this resultant makes angle alpha with x-axis, then tan alpha will be the y component of R vector by its x component. But since Ry and Rx have same value, this value comes out to be 1, and this is possible only if alpha is 45-degree. That means the resultant will be along this direction. This is our R vector. I should not use the word resultant, but that R vector will also make an angle of 45-degree with x-axis. So these were some of the questions which I intended to discuss with you, so as to make the concepts pertaining to resolution of vectors and addition of vectors. If some set of vectors are given, how do we find some operations, say A vector, B vector, C vector are given, how to find A vector minus B vector plus 2C vector using components. So this is the method. Next class we will go over to some more involved questions, but before then I would like you to practice sufficiently and be prepared for the questions that follow. So okay students, till next class, take care, read well.